Yeah, so is this your first interview by any chance?
Yes.
Oh, okay, okay. I'll give you a
Yes.
rundown. Yeah, I'll give you a rundown on what the template is like,
Okay.
and yeah. So, and how many years of experience did you share?
6 years.
About 6 years of experience. Okay,
Yeah, little over 6 years. Yeah.
got it. Okay. Yeah, that's great. Um, yeah, it's definitely a good time. A good point. Years of experience wise to kind of like
Uh,
transition and see what else you can get.
yeah, yeah. I kind of like in my current place. I have kind of my my company has like different applications. I kind of got to work with different teams, and I kind of know the entire space, which is when I thought I wanted to try something different.
Yeah, so I see here you've requested a sorting interview.
Yeah.
Okay. Yeah, we can work through. This is a good sorting problem I have.
Okay.
It's a it's kind of a classic one, but it's a good enough one where it lets me gauge how you solve problems. And
Okay.
yeah, if you've seen it already, just let me know and we could try
Yeah.
something.
Yeah. Sure. Yes.
Um, Okay, sure. So, and if you have seen it before, but
Mhm.
you're not confident in like the solution, or you forgot it, or
Yeah,
you
yeah,
know,
yeah. Yeah,
like
it has been a while. I think I did sorting like 3 weeks ago. And now currently I'm doing trees. So I kind of like I didn't want to do an interview at that point because I was still doing problems, and now I just wanted to check, uh, you know, like what is my level, or how I should be going forward, because it's like
yeah,
every topic I'm doing for a couple of weeks, right? So I just wanted to have a checkpoint and see what how do I do. Yeah.
yeah, most definitely. Yeah, so let's dive into the question,
Yeah.
um, and we'll have time at the end for feedback and tips and things like that.
Sure. Yes.
Okay, cool. So, given an array of numbers,
Yeah.
I'm going to ask if you could identify all triplets that add up to zero. So,
Okay.
yeah. So like let's say we're giving something like 5, 2, 4, 5, 1, 0, 1. And you can also have like a -3 or something. Something like this.
Okay.
We want to identify all the triplets that add up to 0. So an example would
Yeah.
be 1, -1, 0.
Mhm.
Another one could be, let's do 2, 1, -3, for example.
Okay.
And another could be um, 5, 4, or actually, no, that doesn't work. That might be it. Yeah, because 1. Oh, yeah, we could do like 4, -1, and -3.
Uh,
Uh, there might be more, but the idea is
yeah.
um, we could
Mhm.
we these are the ones I quickly see. So yeah, I don't want to take too much time. Obviously, deriving.
Yeah. Sure.
I want to
Yeah.
compute the time. So yeah, the idea is the algorithm is able to identify all possible triplets that add up to 0.
So I think this seems like we have to pick three numbers to sum add up to zero.
I'm sorry.
Yeah, I'm just thinking like I would have to. I'm thinking on ways of like maybe I would maybe sort it, and then like first just sort the numbers, and then try to find uh, this sounds like a combinations problem to me. Like we are finding every we are picking, we are choosing 3 numbers from the list. It is like given a set of n numbers, we are choosing 3 numbers, and those 3 numbers we have a condition that their sum must be 0. So this sounds yeah, if we were to let's say if we were to find just one combination that sum to 0, right, then I would
this I
yeah,
know in the beginning when you're learning all these like techniques with
yes,
like recursion yeah, it's easy to like blur the lines with strategy. That's probably one of the harder parts in interviews, like figuring out which
okay,
technique. Um,
yeah, okay,
yeah. You could, yeah, you could do an exhaustive search, and you can make this a combination problem. It's going to be very difficult though because you're going to
okay.
have to like track. Um,
Mhm.
yeah. So I will just give you a hint up front that it is not a combination problem.
Okay.
Yeah. The biggest hint you have is actually the one uh, you gave yourself when you requested a sorting interview. Yeah.
Okay. Yeah.
There is a non-sorting approach to this.
Yeah.
So yeah, I don't want to give away too much here because
Yeah. Yeah. Yeah.
I
Yeah.
want to
Sure.
translate it.
Yes.
Okay.
Yeah. So it seems like uh, if I if uh yeah, if we were to do this like brute force, let me start with the brute force to see. Yeah, for every, I mean, for every number, I would choose other number and then add up the sum and then loop through the remaining number. So it will be like n cube. So otherwise, is there a way I could reduce it? So I could let me think. So what I would do first is I would just sort the number. So have some ordering, and then go about picking the 3 numbers.
Mm.
So if I like, let's say for this example, if I sort it out, I'm just writing it out like how it would be like it would be like this, and then what I would want to find is a combination of 3 numbers. uh, so I might have so uh, so I can be uh, having like 3 pointer in the start and the end, and if the sum is so I could do something like this. Let's say, to make it simple, maybe I could optimize this later. I could pick the first number, and then in the remaining list, can I get a sum of can I get 2 numbers from the remaining list whose sum would add up to 3, so that the total sum becomes 0? That would be something optimized over the n cube. I think I could have a 2 pointers then here. Like initially, I need to get a 3 in the remaining sum, right? So I would have a pointer at the end and the beginning, and then if like say the pointer would be the left pointer would be at -1 and the right would be at 5, right? So their sum is 4, which is great. With the sum in the left and right is 4, which is greater than so my target is 3 and this is 4, so I would need to reduce it. So then I would move my right pointer leftwards. So it would be -1 and 4. And then, yeah, we have found a sum, right? So because this is sorted, and yeah, this is one combination. And then, uh, so I found this, and then I would add that to the result set. But that could be other combinations. -1 is, I mean, the pointer is here and the right pointer is here. So then I could, so now if I could go, either, so I could decrease the left, I mean, I could move either the left pointer first or the right pointer here. I think it does not matter. Yeah, first let me move the left pointer rightwards, and then, yeah, now, I mean, because I have to get out of this equal situation, right? So now I just moved, uh, the left pointer one step ahead. So now this sum is greater than 3, the target. So then I would have to, get a target, this is 4, I would have to get a 3. So I would just move the right pointer leftwards.
Mhm.
So it would be 0, 2, right? Now this is 2, which is like lesser than 3. Lesser than 3, so I want a higher value, so I would move my left pointer rightwards, and then 1 and 2. So then we have this other pair here, right? And now I could move either, but if I move either, both of them will collide, right? The pointers. So I would say those are the pairs I could get with the starting s -3. And then similarly, I would repeat the same for -1. I would repeat in this list, and 0 I would repeat in this list. So I'm kind of doing, I think the time complexity there would be, for each number I'm visiting the rest, right? It would be n square.
Mhm.
Yeah, that is one approach in which we could solve this n square. And then, yeah, there is this initially when you sort this, I'll issue a library sorting command, so that will be n log n, but then n log n square, the total put together, the time complexity would be n square, right?
Yeah, yeah.
Yeah.
And what is the space complexity?
The space complexity here would be big. Here would be, so I'm given an input space, so I need to output it this way, and I would be using, so the input space is a given, right? And the output space I would be considering. Uh, con- okay, let us talk about the auxiliary space. The auxiliary space would be, I would be just using, 2-pointer variables and a 3-pointer variables, right? So it would be constant space, constant auxiliary space, and the output space would be, I could construct, how many pairs could I construct of 3 pairs summing to 0? Like there could be, it could be n choose 3, the output space. I'm not sure. It would be in the order of, the output space would be, I think, I don't know if I can say the n choose 3 as a output space, or is it like
What do
a,
you mean by n choose 3?
like I'm given a set of n integers, I'm creating a 3, I mean, the output space is, I'm creating 3, several arrays of each of size 3, right?
I'm
Yeah.
sorry. I see what you're saying. You could ignore the output memory.
Oh, okay. Yeah, then I think the auxiliary space would be a constant space.
Okay.
Yeah. So should I code this up? Right?
Yeah. You could. Yes, I think
Yeah.
this sounds like a reasonable approach.
Okay. So let me this. Uh, so I would have a list of integers, and then given a Uh, we would sort the input and let me use a for each.
Mhm.
Actually, no, I need to keep track of indices, right? So let me use an index itself. This I get a bit confused sometimes because sometimes I work with arrays and sometimes with array list, whether this is a size or a length. Yeah, that always I kind of use the autocorrect. But
Mhm.
yeah, so here I would pick, maybe let's call it a pivot because this is something which here or number number one, right? So then given this, uh, okay, and the target sum we are expecting is let me see if it is 3, the left is, yeah, we are expecting, we want a sum of 0, so we are expecting something like this. And then so then we go to the two pointers, right? So left would be I plus 1 and right would be, let me um yeah, there is a kind of optimization we could do here, but yeah, let me go over after I write this code this up. Because I'm using the size, let me have this as a variable. So we don't keep calling the size. Yeah, so I get the left element, get a right element. So sum, if the sum is lesser than target, know the left index. Otherwise, I need the, if it is greater than target, I move the right index left, right? Otherwise, it means they are equal. Then what I do is initialize the result list. So yeah, that could be. Yeah, I would just add the list here.
Mhm.
would do. So it's actually the pivot, which is the first element, left element, right element. I'm not sure it's just the display like this. So this I would add it to the result. Um, Let me see if I'm missing something. So yeah, this I would add it to the result. And then I think when I was running through an example, I encountered a case where, yeah, when it is equal, what do you do? Do you update the left one or the right one, right? I mean, I could choose either. I think there is a cap. I could choose either. Yeah. Anyway, if I update left, the next run it's going to update the right. So I think I would just update the, if it is equal, I would just update the left.
Mhm.
So this would be. Let me check if I'm running into some corner cases here. Uh, yeah. So what I was thinking was I could, yeah, because when I sorted, uh, so when I sorted the integers, I got this. So when I said my -3, when I picked -1 and 4, right? Yeah, it is obvious that okay. I was thinking if we could eliminate some portion, like this would go through each and every element, right? I was thinking if I could eliminate, do some backtracking here. So, so let's say I'm at 2, right? If I'm when this loop is at 2, there's no point in looking at the numbers after this. I'm not going to get a 0 because minus my I've already sorted the input. So because I sorted the input, I would have to make some use of the sorting. There's no point in running the whole loop because I'm sorting. So to make use of the sorted input, I would have to break early, not go until the very end of the sorted list. So initially I could do something like if the pivot is greater than, because we know the target is 0, it's not like target is some k, we know the target is going to be 0. And if the pivot is greater than 0, if the element where I'm at is greater than 0, then the all the triplets would have already been added when I encountered a number less than that particular number. So there's no point in continuing. So if pivot is greater than 0, I would just there's no point in even in continuing further on, right? I think I would just break. Uh, so I think, yeah, even if the pivot is equal to, or maybe if it is even equal to 0, there's no point. I'm going to get a pivot. I would have already encountered something earlier on. So because I want a sum of 0 and I want 3 numbers, uh, the 3 numbers, at least one of the number must be a negative. At least one of the number must be a negative number, right? Actually, let me rethink whether this would actually work. Um, yeah, if I have a -3 here, then yeah, the concern is I should not be having any duplicates because I've declared an array list as a result. I should not be having any duplicate triplets. Uh, so I think, so let me try to kind of, what kind of inputs would break this condition. I'm trying to think.
Well, yeah. So it is possible to have an array of zeros.
Oh, that's a possibility. Okay, okay then. Yeah, then if or I could even have something. Okay, I could even have something like an array with something like this, right? Then I cannot, break in this condition because this is the input and this is the only triplet that is adding up to zero. So yeah, I think uh, this will not work. Or um, yeah, yeah. So this is the code that would be for uh, the input.
Yeah.
So do I need to run it or like?
You don't have to.
Okay.
So there's
Or
like,
let me before I submit, let me actually quickly check again if I miss something, if there is some bug or any. Let me run over. So I'm getting up to that. I'm calculating the target sum, and I'm doing so in this. Let me see what if I is uh,
yeah. So
in -1, right?
you did mention you shouldn't produce like duplicate
Yeah,
triplets.
yeah,
How exactly does it achieve that?
uh, yeah. This one, oh, this one achieves that uh, because when I'm seeing a one, it's just that, like say for example, when I see a one here, I'm always looking at the elements to the right of whatever, because I'm sorting it and I'm processing it sequentially. Whenever I process an element, I'm always looking at the elements to the right of it, right?
Mhm.
So in that sense, uh, I would not encounter duplicates. For example, this one is included in two triplets, right? Which includes even a two, and this one includes a zero. So, uh,
But what if there's like a
yeah,
duplicate like number? Like what if I just added like a -1 here, for example? I just put quotes around it to show that I added it there.
okay, okay. So you wanted a unique, unique triplets. By duplicate, meaning not the triplet duplicates, but even the numbers, the negative one, you don't want to be repeating it twice, right?
Right. Yeah.
Something like
So
that.
like for
Okay.
this, uh, yeah, this would get outputted
Okay.
twice.
Yeah. 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 In that sense, yeah, I would do this. So here, right, if this if I is greater than zero, and uh, if it is equal to the previous one, then I would not, uh, or okay, let me think. So if I encounter a -1, then yeah, I would have to be looking at all the numbers after this. And yeah, I mean, when I encounter here, I can skip it. But when I encounter this -3, I should not be considering, if I consider this, I should not be considering these twice, right? So in that sense, I think an easier way to do it would be after I sort it, I can, there are multiple ways to do it. I mean, either I could skip it in the loop, or to be making cleaner, like after sorting it, I could convert it to a set and eliminate the duplicates that way.
Hmm.
Yeah, that would be an easier way of doing it. or like, yeah, if I'm not allowed to convert it to a set, then I would have to do some checking here to make sure I don't consider it. But then that would make the code a bit more convoluted, I guess, because when I encounter this -3, I should be making sure each number I encounter after it should be a unique one, right? So then even when I encounter, I mean, maybe I could have something like this as well, because when I have the -3, I could have something like -1, and then even I could have 0, and then I could have 5. So that could be duplicates either at either ends. That could be duplicates, and say if I continue storing it in an array list, then it would be difficult. I would have to, add checks to skip. Whenever I move the pointer, I would have to add checks to skip the duplicate elements. So I think a cleaner way would be to, while sorting itself, I could sanitize the input in that before I even traverse it to get the triplets. I would convert it to a set and then uh, start, putting up the triplets.
Yeah. Um,
Yeah,
but how would we get, if we convert it to a set,
yeah.
I don't think we could do things like this on it,
Uh,
right?
oh, uh, yeah. I would convert. Okay, I put. Yeah, then I could, after sorting it, I would. Sorry, I would loop through. I could loop through the input and. Uh, so let me see. I could loop through the input and kind of. You know. Yeah. I mean, easier way would be to create, instead of creating a new set, I could create a new array list and then consider only the unique elements. Like I could pass through every element, and if it is the same as before, I could skip it. That would be just consuming an extra space, an extra variable array list. But then, yeah, and if we need to optimize that further, if we need to, eliminate duplicates in place within the same input list itself, right? So then it would be, uh, do something like, I would take, yeah, I mean, for each number, as long as the current number is not same as the previous one, I would go forward. Otherwise, I would. Uh, so otherwise, what I would do is, yeah, I'm thinking of something like this. I would have one pointer in the end, and I can do again 2 pointers here. I can have one pointer in the end and one pointer. So do you want to go that way? Like, I mean, if I'm
Yeah, I think
yeah,
checking the neighbors is just fine.
okay,
Yeah.
checking the neighbors and putting them into a new array list is okay, right? Or
Well, why would you need to put in a new array list?
okay, then okay, let me go ahead, checking the neighbors. After I check the neighbors, I'm kind of trying to modify the same array list, so that I'm kind of trying to do everything before I actually start the for loop. Are you talking about checking the neighbors inside the loop?
Well, that is up to you, but I think the
Yeah.
idea of checking the neighbors, I don't see an issue with that.
Okay. Yeah, I think I would. Yeah, I was thinking I would move all the duplicates to the end by using a 2 pointers, and then kind of uh, resize the array list, and then just work with, not resize, I think, instead of going all till the end, like for example, I would use a 2 pointer approach to keep swapping, checking the neighbors and swapping, and all the duplicates would be put at the end. I mean, I would do an end pointer and put all the duplicates backwards from starting from the end, right? So initially there would be the -1 duplicate and 0, and then there would be 5. And then what happens is I would have this starting pointer of the duplicate. So I would eliminate all this portion. And then what I would do is, this is the end pointer, and this is the start pointer. So instead of having the n here, I would actually have the n as this pointing to this location, so that whatever I'm running through will be only to this. That way I would have sorted the input. I would have rearranged the input such that I'm getting only these values. I'm going through only these values, and my loop would work with that. So that would be much cleaner instead of doing inside the loop. So I would basically rearrange the input so that all the duplicates are pushed towards the end, and I would have a start index and end index of all the unique numbers, which I would pass to the loop.
You would push. So is this like a sanitizing input approach?
Yeah. Yes.
You would push. So you would like. So you outside. So even before the loop, you'd have some sort of like method that.
Yeah, that I would have something sort of method. Even the sort, I can move it to that. I can call it maybe sort and sanitize, and initially I'll sort, and then I would move the duplicates to the end.
Okay. And you would move them. You would swap it at the end of the array, or something?
Yeah, I would keep an end pointer, and as long as I would keep an end pointer, to just swap it with a duplicate if I find any, and I would start traverse
What if that
the
breaks?
list.
But what if that breaks the sorting? Because
yeah, it would break the sorting, but then I'm kind of like eliminating all of this, because once I have all the duplicates at the end, then it won't break the sorting, right? Because I'm kind of swapping it in place. I'm going
well, like for example,
yeah.
like looking at this example, we would have -3, -1, 0, and then you would, if I understand right, you would do something.
Yeah.
So doesn't that break the sorting, right? Because now we have -1 here, and 0. -1 should be before 0.
So initially I'll be sorting it, and then I would be so this was a given input, right? Given input, and no, this is not the given input. This is the sorted input after I do the sorting. And after sorting the input, I would just move all the duplicates to the right.
Oh, okay.
Oh,
so,
okay. Yeah, I would. Oh, yes, I get what you're saying. I think it would break the sorting. Yeah, it would actually kind of erase this number. Right?
You'd have to track the left. You'd have to track like the right index, and then that wherever your right index ends at, because you're probably going to be decrementing it. That's basically then you'd have to adjust your whole algorithm.
Oh, yeah.
Your end would be
I
different.
think. Yeah, so I think then I would say.
Well, actually, we're a little bit over time, so
Okay.
let's transition to feedback if you don't mind.
Yeah, sure, yes.
Okay, great. Yeah. So let me pull up my notes here.
Yeah.
Yeah. So I thought the interview started off pretty good. I like. I kind of did give. Okay. Well, before we get to that, I liked how you identify the brute force approach.
Yes.
It's order of n cubed. Then you started to suspect a twosome approach, which was another way we could have done it. And as soon as you suspected that, you found the two-pointer approach, which is even better since this is a sorting interview.
Yes.
And then you proceeded to identify the time complexity, which was correct. The space complexity is a little bit trickier since we are doing a collections.sort, which means depending on the sorting algorithm used, it could vary from log n to order of n because of the recursion used. If we use quicksort, there's some recursion there. Now for merge sort, um, there's some auxiliary space that could be in the order of n to think about.
Mhm.
So due to the sorting algorithm, the space complexity could vary from log n to n. So it's
Mhm.
actually not constant time. Okay, so let me pull up the notes here, make sure we get
Mhm.
everything. Yeah, so that's for the space complexity.
Yeah.
Now, yeah, so we just talked about the space complexity of the sorting algorithm. Uh, I ended up having to give some hints for the zeros edge
Mhm.
case. So let's talk about some things we could improve on, right?
Yeah, yeah.
Um, so there's like some minor things, not necessarily showstoppers.
Yeah.
Uh, there's some hints I gave for the zeros edge case. It's not so
Mhm.
bad. I think you can assume at least one hint per interview
Mhm.
is not that bad.
Yeah.
You could have done less than or equal to zero, or I'm sorry, greater than zero. I think your reasoning was good there, but there was a slight issue with if it equals to zero, right? Uh,
Yeah.
yeah. So I wanted to point that out because to me, maybe like that that you know, if you could reason through like why you think greater than zero would have worked, and the
Uh,
interviewer doesn't agree,
no, no.
doesn't.
Where in greater than zero is it
Yeah,
like?
so you made the observation that for positive integers, since your search space is to the right, right? Like once you
Yeah.
pick a pivot and you look to the right,
Oh, okay. Yeah, that one.
mhm,
Right. Okay. Yeah.
yeah. So you just made the observation that you pick a number, a positive number, and if you look at the search space to the right, it's
Yeah.
nothing but positive numbers. So it's impossible, right, for it to equal
Yeah.
zero.
Yeah. Yes.
So unless your pivot is zero itself. So,
Yeah.
if your pivot is zero itself, it's possible to the right, there's more zeros. So, let's just ignore, let's just say zero is negative or something, and your algorithm would work fine if you did greater
Oh,
than
yeah.
zero.
So if I have put pivot greater than zero, then break, right? This would have worked.
Yeah, I think that should be
Yeah.
fine.
Oh, okay. Yeah, I got a bit confused there.
Yeah, that one isn't too big of a deal.
Okay.
So yeah, the
But this
kind of
would still be an optimization, right? I think in
yeah, it would be a slight
terms of time.
optimization for
Yeah.
certain. Um,
Okay.
but in general, this algorithm does run in order of n squared, so it would be an optimization, but
Yeah.
it would the biggest optimization it would
Mhm.
probably be for inputs that have a ton of positive numbers.
Oh, yes, yes. It depends on the input type of input also.
Right, exactly. You wouldn't see it for like something with like you probably wouldn't see it for like a balanced array. Um, you would probably see it. I mean, depending on how large the balanced array is, you'd probably see it.
Yeah.
But you would definitely see it for inputs that have a small number of negative numbers and a large number of positive.
Yeah. Another thing I was thinking was I sorted the numbers, and if the last number is a negative number, even then I can just return. I need not go through all this. I can just return that there cannot be any triplets, or maybe I don't know if I have to do things like that.
That is, yeah, that's another optimization. These are
Yeah.
kind of premature optimizations. I wouldn't worry too much about premature
Okay. Yeah. Yeah.
optimizations.
Okay.
I would focus more on the logic and making
Yeah.
sure, you know, like those are kind of nice to haves, but
Yeah.
it's
Yeah.
not. Yeah, think of it like I don't know, like a lower priority optimization. Uh,
Yes.
Yeah, because they don't really impact the time complexity, right?
Okay.
Yeah. So although they're good to think about,
Yeah.
I wouldn't I probably wouldn't waste too much thought into kind of I would spend more energy around thoughts that impact the time complexity.
Okay.
So yeah, let's see here. So then, yeah, you mentioned the set usage, but there's some issues with that.
Mhm.
Um, and that one is kind of like a yellowish flag
Okay.
because
Yeah.
uh, Yeah, I
No,
mean,
I was thinking I could convert it to a set to eliminate duplicates and again convert it back to an array list. I don't know if that is,
it's a
yeah,
little too
because I
much
mean,
work, I would say. Like,
yeah,
it's more work than necessary.
okay.
Um, you actually did have some code that was correct the first time. Unfortunately,
Oh,
you moved away from it. You had some code that was checking the neighbors where you just looked at the previous element.
yeah, I could see I could have it. I mean, I could have it here if the uh, like I
It's
mean,
okay. We don't
I
have
could,
to we don't have to run through
I
each.
could have it here to see if the left element is still. I mean, if I could increment. I mean, once I increment, uh,
Yeah,
or
you don't have to like
yeah.
yeah. I would
So yeah,
say probably
my confusion was where would I add the check? Whether I should add it in the if
yeah.
block and else block, or I should add it here. So that was why I was thinking more twice to even consider that approach, because I'd have to be eliminating duplicates. If I'm having, I mean, if I get into this while loop, I would have to be eliminating duplicates from both ends, right?
Yeah, so I think
Yeah.
you can have it inside the for loop. You don't need it inside the while loop because
Oh,
essentially what we're looking for are duplicate pivots, right? So if we run into a pivot we've already processed by looking at its previous neighbor, you would know at that point in the code
yeah.
that
But
we've
what if,
already
like, say I look at this, yeah, this one I would eliminate. But what if I look at this negative one? I would be starting from the end pointer. I would be starting from here, and here both of these fives would be considered, right? Is that still okay? No,
yeah,
I
that's
mean, it
fine.
would not. Okay, yeah. That anyway, they were not going to be in the result, but yeah, that I think that is still okay. It's just that
Yeah,
the pivot must not be a duplicate.
exactly. Yeah, the
Yeah.
search space can still have duplicates because we don't care if the search space has duplicates. We only care if the pivot
Yeah.
itself is right.
Okay.
Yeah, so that could probably go inside the for loop, and I would encourage you to do like more thought experiments just to make sure you have you don't have any confusion around why because what you mentioned right now those are kind of like good thought experiments to convince yourself
Okay.
why something
So
works.
when I do those thought experiments, do I actually speak it out? For example, I was like, okay, let me convert this to a set, and then oh no, I mean, then yeah, I got caught that this will not work, right? So if I happen to think of something which I'm not actually very clear, but then do I still speak it out, or no? I still think twice before actually letting speaking it loud.
So that is kind of a gamble, I would say.
Okay.
If you because we will like it does vary per interviewer.
Yeah.
You have to. What I will say is a good balance is um, I think it's good to speak out your confusion if you have like doubts or confusion. You can
Yeah, about
speak it out.
clarifications, right? Yeah.
Yeah, or sometimes the interviewer jumps in and they try to like course correct and tell you things like
Okay.
maybe what not to think about. You're probably okay here. So sometimes it helps. But
Yeah.
if you start yeah, if you start looking for too much like if you start looking for too much or if you start talking about too much confusion, it can
Yeah.
also hurt you in the sense that now
Mhm.
the interviewer might not be as confident like okay
Okay. It's like he's
yeah
confused. Okay. Yes.
so I would say in the least like
Yeah.
but at the same time you don't want to just stay quiet like you don't
Okay.
because if you stay quiet for too long that's also a
Yeah.
problem yeah.
Okay. So when I'm coding it up, okay, discussed the approach, and when I'm coding it up, I would. I mean, I would have to be keep saying I'm doing this, that, right? Because then otherwise, I thought there would be again a period of silence when I'm coding it.
Right, right. So I would say just like focus more on uh like just do the pseudocode or something.
Yeah.
I would say do the pseudocode first. I kind of skipped that, but pseudocode is really good, especially for identifying the logic and the edge cases.
Oh, you mean I write it up like a comment section in the pseudocode or something?
Yeah, yeah, like coded in
Okay.
English. That's like the best way I could.
Yeah.
And the nice thing about it is you can probably write English faster than like any programming language.
Yes.
Yeah, so it's like it's syntax free, and
Yeah.
it's very more. It's a lot more logical. And yeah,
Yeah.
I tell, especially for fast app coding, I think your speed here was really good. So I think
Okay.
if you're fast app coding, like you could focus even more time on the pseudocode. By the time you're done with the
Okay.
pseudocode, you're probably
Mhm.
just run through the coding part because you're
Yeah,
gonna,
yeah.
yeah. So okay, so this kind of leads into something else I noticed.
Mhm.
At some point, it felt like you were looking for like a little too much validation of your code.
Okay,
Uh,
okay. Yeah.
yeah, unfortunately, like you don't want to ask. Like I think it's good that you do ask for interviewer validation because I do
Yeah.
encourage that. I notice sometimes people don't do it at all,
Mhm.
and I don't understand why. I think when you feel confident about a solution, I think it's very okay to look at your interviewer, um, or if it's digitally, just ask your interviewer and just tell them like,
Okay.
hey, this is what I think the answer is.
Yeah.
Can we proceed? And at that point, the interviewer can make a choice like, yeah, we should proceed, um, and you know, or they can say like, well, there's one bug or one edge case I think that breaks this, and
Okay.
you guys can move from there. So I think doing it once or twice is fine, but I
Yeah.
think there was a point where you were like kind of asking me where should this code go, and you never want to do that because obviously you want to those are things you should probably reason out like code placement and logic stuff
Okay.
unless you're stuck um,
Yeah.
completely and you just kind of explicitly ask for a hint like you need to get on
Okay.
um,
Yeah, so I was asking more on that too. Okay, yeah, maybe when I was asking whether I should be looping, I mean checking for duplicates inside or outside, right? That is a decision you say I would have to make and justify something.
yeah, I would
Okay.
say like yeah, that's something like yeah, because I think you said something along the lines of like what do I think about that
Oh yeah, yeah.
or
Okay,
what do you,
okay.
yeah.
Okay, that
So,
I thought I was thinking more on the lines of like initially when I discussed the brute force approach and the n cube and n square, I thought it would be this the question would be more on the sense like okay, I'm going to do this or yeah, I don't know why that question came up whether to yeah,
yeah,
maybe I should have
it's
decided
okay.
on that. Yeah, yeah,
Yeah,
yeah.
no, it's okay. That's why we're practicing here. So
Yeah.
that's like it's not necessarily a showstopper. It's just something
Yeah.
to think about.
Yeah.
And okay, so this is probably the biggest red flag that came. Unfortunately, it was towards the end of the interview.
Yeah.
Um, the duplicate approach, the one where you pretty much had the solution, but then
Okay.
unfortunately you moved away from it. It was like
Okay.
taking the previous neighbor one.
Yeah, yeah.
Um, yeah, I would definitely encourage you to stop, and just slow down and like really think about it and just be more confident. Just try. I know that's
Okay.
that's easier said than done.
Yeah.
It's hard to just tell someone be more confident in your solution.
Yeah. No, I
Uh,
was like, okay, when I introduce this, and then okay, after I submit, then what if the interviewer says, oh, this might not work for this case, and that's where I was
yeah,
afraid. Yeah.
I think that part, unfortunately, it felt like you might have overthought it slightly because
Okay.
your initial gut instinct had the answer, but then you started to
Okay.
think a lot about it, and you
Yeah.
started thinking like, okay, I'll move all the duplicate numbers at the end of the array. Now you're gonna have to have a separate index at the
Yeah.
end that cuts off the duplicate numbers from the real array, and like now this you'd have to track that end index. You'd have to carry it to the algorithm, the three-sum algorithm now,
Mhm.
because now it's like you can't. It's not I less than n. It would have to be I less than that special index or something.
Yeah.
So like, I could see that solution working, but it's a lot of work, probably
Yes.
unnecessary. Like it's like an unnecessary amount of work. So
Okay.
I would say that was probably the biggest kind of like red flag,
Yeah.
unfortunately,
Yeah.
because the hope is up until that point it was actually looking really good.
Okay.
It was
Okay.
looking pretty good. I don't
Yeah.
want to say really good, but it was looking pretty good because you there was because really good is when you're solving all the edge cases, and this was an edge case. We kind of got stuck in.
Yes.
But basically, you were looking good. I will say that you were looking good.
Yeah.
And then that kind of made things a little bit trickier because
Yeah.
you know, since you were problem solving this good, because I thought your problem solving skills were uh, doing doing pretty good when you
Mhm.
identified the sorting, when you identified the 2 pointer approach.
Mhm.
I would expect like that edge case to not have thrown you in so much of a loop than it did.
Okay. So
Yeah,
this what you call it a edge case. Like initially, I mean, I was thinking edge cases are more to do with the pointers, right? Whether I mean, here I have like if you use pointers or some variables, they don't go over the array size. They don't go throw a array index out of bounds or a null pointer. Those are the ones I've been thinking on edge cases. But that this one where the input might actually the kind of input that might break the code, yeah, that I feel kind of difficult to come up with. Yeah, for example, yeah, the duplicates did not strike my mind at first, but yeah, then I think I would have to always maybe have
I
clarified
mean, I
whether
don't
the
know.
input could have
Yeah,
carried duplicates.
I don't know what like the formal definition of an edge case is. Like, I
Yeah.
guess my definition is like kind of the kind of the items you mentioned, like maybe null input, maybe empty input, maybe to me an edge case is also uncommon in
Yeah.
input that's maybe not common, or maybe input that is common, uh, and it frequently breaks the like kind of the general logic of the algorithm, what the algorithm
Yeah.
assumes versus like special cases. Like if you in this case, the I call it an edge case because you could have duplicate numbers, which causes this edge case, right?
Okay. Yeah,
All
so
of a
initially
sudden,
should have the question when you gave the list of input numbers, right? Should I have asked a question on whether the
yes, yeah.
input contain duplicates, or I should assume that the input
You
would have
yeah.
duplicates?
I mean, like even if you don't ask it, it's okay as long as you could identify
Yeah.
the edge case later. But if
Okay.
you do ask, that's what the best case scenario is. Obviously, if you identify the edge case as early as possible.
Okay. Yeah, I think even given a set of, if a problem states given a set of numbers, those so and so, then I should assume it has duplicates, right? Because if I ask the interviewer, "Oh, will this have duplicates?" then he might say, "Why not?" Right? Because that's just adds an additional case. Like, I mean, it's not that the interviewer is going to say no, there will not be any duplicates, right? It's or there could be a chance. I don't know. Maybe it depends on the problem.
Yeah, um, you do want to just identify. I say identify the edge cases as early as possible, and identifying
Okay.
edge cases isn't always easy.
Yeah.
Um, so if you could identify them early, I think it's even better because at that point you can start to think about the general
Yeah.
logic and also maybe some additional kind of code you'll have to add here and there just to account for something.
Yeah.
Like for example, you have the general coding right for this portion. Um,
Yeah.
I mean, there's some things you're missing, but it's not like like a return statement or something. Like you have the general
Oh,
logic right. There's some things you
yeah.
could have done shorter, but if when you think about it,
Yeah.
the edge case of like checking a neighbor, for example, it's
Yeah.
it's like a single if condition that solves the edge case, right?
Yes. Yeah.
So yeah, exactly. I mean, yeah, you would just do like if pivot equals input dot get I minus one, right?
Oh, yeah. I would do. Yeah. If uh, I would do something like if I greater than zero, right? And then
I mean, you're kind of mixing a premature optimization with the edge case,
oh,
so
so
maybe
this
just go
is an
like
optimization.
yeah, that's I would consider that a premature optimization. So let's just ignore the premature optimization
Yeah.
just
Yeah. Yeah, I would do
because
something like this is what I was thinking. If it is like this, then I would just continue. Right?
Yeah, exactly. So
Yeah, this one is needed because otherwise I would get into a negative number, right? So which is why, yeah, you need to be checking only from the first number onwards.
yeah, so yeah, so exactly something like that would work.
Yeah.
So like the algorithm looks clean, and then you have this random if statement. That's when you know it's most likely for an edge case, right? It's like why
Oh,
is
yeah, I would have to maybe add some comments here, and then I would have to decide on the
exactly like
sequence
if you did
sequence of,
if
yeah,
you
I would have
exactly
this
like
earlier.
it's usually, yeah, usually edge
Yeah.
cases require some sort of comment. Like, if somebody goes through
Oh,
this
yeah, yeah.
algorithm and they'll most likely understand like, oh, this
Yeah.
kind of
So
approach.
here we have found all possible triplets.
Exactly,
That's
yeah.
why we are breaking.
And then you
This is
probably
for the duplicates. So here I had a concern. This would still, I mean, okay, it would not go through all this while loop, but then it would still run from. Yeah, it would not. It will just break continue.
yeah. So yeah, so I think that ends like the feedback portion. Did you have any questions? Yeah, did you have any questions for myself?
Uh, no, yeah, those are. I think I have asked all the questions. Yeah, and this one here, do you think adding? I don't know. I could have even done this. I could have implemented both pointers and added. I mean, skip
Yeah,
the loop iteration, but then I
yeah,
just
I
thought,
would do both because it's kind of like a thought experiment. Like it's like
yes,
kind of a
yeah, yeah,
mathematical thought experiment. But yeah, if you think about it, if you found two numbers that add up to like let's say the number two, um, and the only way
yeah. I
if
was just concerned if I move both of the pointers, would I miss some edge case? Which is why I was careful on just moving one pointer. But
yeah,
I think it
because if they
was,
if they add up to a number x, the only way they can add up to x again is if
yeah,
the left or right equal the same number, right? In which case we
yeah,
want to ignore it because
yeah,
we've already added it, we've already tracked it anyways,
yeah.
right? So um yeah. Yeah, did you have any other questions?
No.
Okay, great. Well, I think
Mhm.
we could probably wrap up here at this point.
Yes.
Okay, cool. Well, Vanan, thanks for
Mhm.
bearing with me. I know
Yeah,
it was
yeah, yeah. Will that be something like a report or something sent to me? Or,
yeah, yeah. So the way it works is I'll
yeah,
give you some online feedback.
yeah, yeah,
It's mainly stuff that we really talk about. I'll just sum it up, and then
yeah,
I'll give you some scores.
yeah,
Uh,
yeah. Sure. Yeah,
yeah, don't I try to tell people don't ever get discouraged by the scores.
yeah,
Uh,
yeah. It just tells me where I am, so I could improve upon next time, right? Yeah, that's fair.
exactly,
Yeah, because
exactly.
this is my first interview.
Yeah, yeah. You definitely didn't do bad for your first interview. Uh,
Yeah. So it is just concerning that it has been like 6 years since I interviewed last, so it's kind of all new. But yeah, which is why I'm trying to overthink. Sometimes I kind of overthink it when I'm speaking out the solution because yeah, but yeah,
Yeah, yeah, no, definitely understand. It's okay. It's okay. I
yes,
would say keep consistent and keep working on the problems. Try to at least do two a week. If you can,
yes,
you should do one every day. Like the best case is you do one every day. And you like just don't spend 6 hours on a problem. You spend
yeah,
like 1 hour. If you're really curious, spend two. But I would say just make sure if you could do a problem a day, even better. And don't spend too much time on it.
yes.
And if you're as long as you're staying consistent, you're getting a good night's sleep, your brain is gonna
Okay, and say if I for these IK practice problems, like every class, I think we get some class problems and practice problems. If I some these practice problems are medium hard level, right? Sometimes I kind of the solution that doesn't come up to my mind. I don't look at the solution. I overthink. I keep thinking about it, and then it takes like 1 hour, 2 hours, and I still think about it. Is that okay to continue like that? And maybe something comes up at the fourth hour or fifth hour. Maybe I keep thinking about a problem, drawing it around. Like maybe half a day I spend sometimes for a hard problem, and then something comes up. Is that still okay, or am I spending more time by doing that?
I would say spend 1 hour max on a question. If you can break it,
Okay.
if you don't have a breakthrough on it, I would say see how other people think about it. Just look at the answer, not just look at the answers, but
Yeah.
but see how. Like usually, I recommend lead code discussion section.
Yeah, or do I just go to a shop for a coaching session and get some hints? I think I don't know how bad would it be an idea. I don't want to actually look at the solution because then it kind of confuses me. Like how I mean, if I just get some kind of a hint, maybe that would lead me to the solution. I don't know if that would be a good thing to do instead of and it also depends on what kind of how the hint I get, right? Like because sometimes it's like the hint is closer to the actual solution, then there's no point on the hint. And
So like what I've
yeah,
learned is you don't want to, if you do look at the code,
yeah,
because I have had to look at the code to reverse engineer like sometimes, but
okay,
what I learned, because there was times where I was reverse engineering the code and I realized
yeah,
there's really not much value reverse engineering the code.
yeah, yeah,
There's
yeah,
what you really want to do is reverse engineer someone's thinking, right? That's
okay,
like, especially if the code is optimal. You want to
yeah,
like, I think that there's so like just getting that like I would say just getting that kind of mindset right when you
yeah,
look at someone else's code. First of all, you definitely want to find, and there's a lot of opportunity. There's a lot of content on lead code discussion section where people do explain what they're doing.
yeah,
Those are the best posts because you don't have to reverse engineer their thinking. You could just kind of like see what they say, and they make it easier
yeah,
to reverse engineer their thinking.
okay,
There's times where people provide optimal solutions and there's not much explanation.
hmm
Those are the hardest because now you have to reverse engineer someone's thinking without any guidance.
okay,
But I think I think like the approach is still kind of like reverse engineering someone's thinking
yeah,
versus and this is the worst case, right? You
mhm,
know, you don't have a coach available, you don't have a friend available, you're like left to your own like tools,
mhm.
and it's a problem you're struggling on, which makes um,
Okay. Okay,
but
maybe I'll discuss with the cohort or something like, and
yeah,
then,
you could
yeah,
always schedule a session and just kind of like instead of doing an algorithm like interview, you could just say like, "Help me understand this problem" or something.
yeah,
Or but the bigger point I want to make about that whole approach is just make sure because a lot of people they'll spend 6 hours on a problem and not
mhm,
enough time reviewing the solution. And I think it's backwards. I think if you get stuck on a problem for an hour or two, just like give up and learn about the solution, and then come back to the question a week or 2 weeks later, and then try to see if you truly understand it versus recalling it from memory.
okay,
Yeah. So
okay,
I can offer more tips or anything if you like schedule another session. If you
mhm.
just tell them like you're requesting me, and we can like talk about more tips on lead code and
Yeah,
coaching stuff like
yes,
that.
yeah.
Yeah.
So, but you recommend me practicing on lead code as well in addition to the IK problems?
I say uh, you use the resources in IK for the
Yeah,
whole
yeah, yeah.
for like the 2 months,
Yes.
um, and then you translate what you learned in IK and take it over to lead.
Okay.
Because in
Yeah.
theory, if IK is doing their job right, which I hope
Yes.
I am, and I hope IK is, um,
Yeah.
you should be able to solve easy and medium questions. You should have, your percentage of success should increase on lead code. So I think you should,
Yeah, I
you
think even this
definitely,
problem, right? I don't. I initially I thought, oh, I have not seen it before, but then when I started solving it and the 2 pointers, then actually I remembered that it was maybe somewhere I saw this. I mean, I got this one is actually a two-sum problem, right? Maybe I did not see the exact problem, but then this pointer approach I got it from the two-sum
Mhm.
what
Yeah,
we have
yeah.
all yeah.
Yeah, that was definitely right.
Yeah.
But just keep in mind, like in the beginning, you, I think you started going down the combinations route.
Oh yeah, yeah,
Um,
yeah, yeah. Yeah,
so
I
just
thought
spend a
I
lot.
could do an include exclude because I was just in that mode, recursion mode, right? So I thought I would just do a. I mean, I could go to every number and do a include exclude, and then but then I could do that. It would become like NQ.
Well, if you do, if you do an exhaustive search, I think that's
Yes.
worse. I think that's
Oh, it's a factorial or something.
yeah, that's going to be a factorial. I think because
Okay,
now
yeah,
you're
yeah, I'll keep that in mind. I should not be doing exhaustive search unless it is for a limited number
yeah.
set of numbers and
I think
yeah.
that kind of like decision making, deciding what technique to use, is very
Yes.
difficult. And I think to me personally, that requires a lot of experience with doing a lot of questions on.
Yeah, okay. I was no big why I came up with that approach is because like I remembered vaguely something like a set of uh given a set of input is a set of characters
Yeah.
or input is a string generate all strings that can be of length 3 or something like that, right? In that case I would go with the
Okay.
combinations.
Yeah. Right. Right. Yeah. It's a that's fine.
Yeah.
I think just once you do enough questions, you'll have
Yeah,
more
yeah.
confidence with what technique to use.
Okay.
Right, yeah, because that is like a tough thing to do. In the
Yeah.
beginning, that was I know I had a tough time deciding like which technique do I use. They all look the same sometimes, especially for
Yeah.
like, strings, arrays, DP. Those can like greedy algorithms, DP and strings arrays. They're all
Yeah.
very similar. So that's always kind of a nightmare for anyone. But yeah, like I think with as you solve more and more of these questions, you're
Yes.
going to start to develop like kind of a second nature. Like, oh, this is definitely screaming two pointers. This is definitely screaming,
Yeah.
depth first search. Like you'll be able to reason it better in your head for sure.
Yes.
But yeah, but it does take some time to get there. So that's why I say, keep consistent. Just keep consistent. And I try to tell everyone like you don't have to be a genius. Just keep
Mhm.
consistent, and you're definitely going to see results.
Okay. Yeah.
All right. Well, with that being said, let's just wrap up here. But yeah,
Yes.
good luck, Vinod. Have a
Yeah.
good rest of your evening.
Yeah. Thanks.